You guys know how this goes. Each and every unit, we transform the parent function. So when there's a number being added or subtracted right on the x, we call this inside the function. It's a horizontal shift. Now, subtracting a number from x is kind of the opposite of what you would think and sends this function to the right each unit. Adding onto that x is again opposite of what you would think. It moves the function left 8 units. When you subtract a number on the outside of a function, it's a vertical shift, and it's exactly what you would think. Minus k outside this function will move it down k units. Adding a k on the outside of a function moves it up k units. This negative sign out in front, you guys know by now, is just a reflection in the x-axis. Go ahead and fill out this column on the right-hand side for logs. We can use all of that to figure out the domain and range of these functions without even really graphing them on the calculator. If you look at this function, it's the function log base 3 of x moved up 4. So the translation on this parent function is that it moved up 4 spaces. We can sketch this curve. The basic graph of a logarithm looks like this, but this specific logarithm got shifted up 4. So it is going to look more like this. Its domain stays the same as it usually is. X is just greater than 0. Its range still remains the same. Y can be anything. In example 2, it's the same deal except we have an exponential function, 5 raised up to the x minus 2 power. This minus 2 on the inside sends this function to the right 2 spaces. Again, we can sketch this curve. The parent function of an exponential looks like that, but this specific exponential got shifted to the right too. Just like before, this shift doesn't affect its domain, range, or asymptote. Its domain is the same as always. X is all real numbers. And its range is still the same. All the y's are greater than 0. Try 3 and 4 on your own.
Do you feel alive?
I feel happy of myself.
I feel happy of yourself too. What, do you got any words of wisdom? What about for all the other kids trying to learn how to ride their bike? Can you say anything to them?
Everybody, I know you can believe in yourself. If you believe in yourself, you will know how to ride a bike. If you don't, you just keep practicing. You will get the hang of it, I know it. If you keep practicing, you will get the hang of it, and then you can get better and better at it as you do it.
Give me some thumbs up.
Thumbs up, everybody!
All right.
For rock and roll!
Here's something slightly new. What happens when you multiply a number in front of an exponential function like this constant a? You guys know that that's considered a vertical stretch or shrink depending on if a is greater than or less than 1. For exponentials, though, it means something a little bit more special. If we graph the function 4 times 2 to the x power, we see that -1 maps to 2, 0 maps to 4, 1 maps to 8, and 2 maps to 16. We can plot these points to get an idea of what this curve looks like. This is an exponential with an asymptote that is the x-axis, just like always. But something very special about this function is its y-intercept. You'll see that its y-intercept is the same as that a. This a value is known as the initial value because if you plug in 0, That is the output at time 0. This point, 0A, is not only the y-intercept, but it is also the initial value. This fun fact makes it very easy to match functions with their graphs. Try to match 1, 2, and 3 with graphs A, B, and C. Pay careful attention to the A, the constant, multiplied in front of these exponential functions. They are the y-intercept or the initial value.
오빤 강남스타일 낮에는 따사로운 인간적인 여자 커피 한 잔에 여유를 아는 품격 있는 여자 밤이 오면 심장이 뜨거워지는 여자 그런 반전 있는 여자 아름다워 사랑스러워 그래 너 hey. 그래 바로 너 hey. 아름다워 사랑스러워 그래 너 hey. 그래 바로 너 hey. 지금부터 갈 때까지 가볼까 오빤 강남스타일 강남스타일 오빤 강남스타일 강남스타일 오빤 강남스타일 에이 섹시 레이디 오빤 강남스타일 에이 섹시 레이디 오빤 강남스타일